Okay, FRQ2 started with a non-calculator problem from 2016. Reminder that FRQs, you typically speaking, have 15 minutes per FRQ. At this point, we're operating under the assumption that will still be the case this year, but this Friday, April 3rd, their College Board is going to release their plan, and so we'll see if that changes at all. But so far, FRQs, so you've always had 15 minutes per FRQ. So for this one with 3 parts, that would mean you'd have 5 minutes per part. So you have plenty of time to slow down, check your work, make sure you're good to go. I'm going to do this FRQ in the following order: A, C, and then B, because over the years I've noticed that's the order students typically do it in. I think because A and C are the ones we're kind of expecting from a slope field problem, while B, which is a common question within the AP test as a whole, so it's important that we understand B. I wouldn't say B is the one we're expecting when we hear we're going to be doing a slope field problem. And so again, we're going to do A, then C, then B. Okay? So A is worth 2 points, 1 for the zero slope, 1 for the non-zero slopes. We're on the axis providing, sketching the slope field for the 6 points indicated as we talked about in class. I always give myself a little x, y, dy, dx chart. You don't have to, but I'm going to. And so my points are at 0, 2, 0, 1, and 0, 0, and then 2, 2, 2, 1, and 2, 0. And then we're plugging each of those points into our y squared over x minus 1. So our 2 is going into the y, because that's my y. So 4 over my 0 into my x. 0 minus 1 is negative 1. 4 over negative 1 is negative 4. And we're going to do that for each of them. 1 squared, 1. 0 minus 1, negative 1. 1 over negative 1 is negative 1. 0 squared, 0. Over 0 minus 1, negative 1. 0 over negative 1 is 0. 2 squared, 4. 2 minus 1, 1. 4 over 1 is 4. 1 squared, 1. 2 minus 1 is 1. 1 over 1 is 1. 0 squared, 0. 2 minus 1 is 1. 0 over 1 is 0. And so you've got your 6 slopes here. At 0, 2, we're going to be drawing in a slope of negative 4, which is a pretty steep slope, right? If I'm aiming, so here, if I'm aiming at this point here, that's only a negative 2 slope, right? Down 2 over 1. So we're going to be aiming even lower than that. So we're going to have a pretty steep negative slope here. Negative 1 slope at 0, 1, down 1 over 1, we're aiming right at that chord, or at that point there. And then 0 slope should be flat. Okay? Same on the other side. Positive 1 here, positive 4, which is going to be pretty steep. Okay? And so again, 1 for your 0 slopes, 1 for your non-zero slopes. Okay, going down to C, which is where we're going next. C is worth 5 total possible points. We are finding the particular solution, y equals f of x, to the given differential equation with the initial condition f of 2 equals 3. Particular solutions are originally in Unit 4. It was at the very end of 4.1. We then did them again in 5.7 and 5.6 a little bit, but mainly 5.7. And then again as we were learning slope fields right before school closure. Okay? And so, doing our particular solution here, my derivative is dy dx equals y squared over x minus 1. Your first point in this problem comes from the very first step that we've talked about since 4.1, which is you have to get your variables on either side. And remember, we will always multiply the dx, we will never divide the dy. And so if I multiply that dx over, that means we're going to want the x's on the right, the y's on the left, meaning I'm going to leave this x minus 1 over here with the dx, but this y squared, I'm going to divide that y squared onto this side with my dy, and that's a point. Okay, if you don't separate your variables, there's a note on the rubric, as always, that you will get 0 out of 5 if you don't separate your variables. So remember what we talked about, you have to remember to do that. Probably one of the most important steps within this problem. Okay? Next 2 points come from your antiderivatives, your two integrals here. So on the left-hand side, this one looks like the natural log. It's very tempting to want to call that natural log of y squared, but remember this is y to the -2 over here. And so this is power rule. Adding 1 to the exponent, we would have y to the -1. Dividing by that new exponent is -1. On the right, this one is natural log. You can do a u to u on the x minus 1 if you want, but our du would be 1, and so it's not actually required. But you could if you'd like. And then don't forget your plus c. There is another note on here, as there has always been, which is if there is no plus c, you get the maximum 3 out of 5 points. They will stop grading your problem at this point if you don't have a plus c at the back of your integrations. Okay? And so 2 points for your antiderivatives there. Okay, and then your last 2 points come from finding your c, solving for y. And remember what we talked about, which is you could do this a couple of different ways. It does then change your work, and so if you solve it one way and it doesn't match my way and you're like, I don't know if I did it right, take a picture of it, send it to me. I'm more than happy to check it for you if you would like. For me, I went ahead and plugged in and solved for c first myself. I felt like that was easier. Although I am going to take a moment and rewrite this as -1 over y, getting rid of that negative exponent there. And so I plugged my 2 into my x spot, my 3 into my y. And then remember, you don't have to simplify at all. So when you look at the rubric that I uploaded, they did simplify this to solve for exactly what c is, because this is the natural log of 1, which is 0. And so that means c is -1/3. Okay, but when I did this one, honestly, I subtracted that natural log of 2 minus 1 to the other side, and I called it good. Okay, not because I don't know what the natural log of 1 is, but because, again, remember, normally, again, it's going to be different this year, but normally speaking, you're doing this problem after almost 3 hours of testing. Like, that's, your brain's tired. You don't want to risk making a small error. Even this year, what if this is after 45 minutes of testing, right? Like, your brain is, again, going to be tired, and so don't simplify if you don't have to. Right? And so then taking that and plugging it back into my equation, we have -1 over y equals natural log of x minus 1, and then plus my c, which is -1/3 minus natural log of the absolute value of 2 minus 1. And then as we were working on ones like these in class, it looked like most people, so I saw some people who spun the fraction, but it looked like most people actually preferred multiplying by y to both sides. So let me go ahead and do that. And then dividing this element underneath the -1 on this side to get y by itself. So -1 over the natural log of absolute value of x minus 1 minus 1/3 minus the natural log of the absolute value of 2 minus 1. Okay? Okay, so again, if there are any questions on that, if you work through it a different way, send me an email. I'm more than happy to check it for you. Okay? Or to walk through it on a video if that would be helpful, just let me know. Okay, our last one here, B, our last 2 points for this problem are the ones, like I said, I usually see people skip and then come back to when it comes to working through this problem in particular. Again, I will say that this is a fairly common question, though, on the AP test, so it is important that we make sure we understand what's happening here. You've actually seen a couple like this already. What's going to be new for this one is that last statement, to use your equation to approximate f of 2.1, but I'll show you what that means when we get there. The first thing that we need to do is write an equation for the line tangent. We've done several of these already if you've been doing your homework and actually checking your work. Writing an equation for the line tangent is y minus y1 equals m times x minus x1. And this is worth 1 point, which I know sounds like not a lot, but the reason why is they've given you almost everything you need. You just need to know this direction and be able to plug stuff into the appropriate spots. Because the first thing we need is our y1. Well, when x equals 2, So let me go ahead and stick that back here in my x1 spot. When x equals 2, my y is 3. And then I need my slope. My slope, remember, is the same thing as derivative. Well, they've given me my derivative. And so my derivative is my y squared over my x minus 1. My y squared over my x minus 1. And if you leave it there, you just got your point. You can simplify this if you want to. It simplifies to 9. But again, I mean, look how easy it would be to accidentally put 6 if you weren't really paying close attention. And so I don't recommend simplifying unless you have to, because this should simplify to 9. And then use your equation to approximate f of 2.1. Well, that means f of 2.1 would be using my equation. This is x, right? F of x. I'm putting 2.1 in here. This would be 3 squared over 2 minus 1. My x is 2.1. And then adding this 3 over, we have our approximation. And again, don't simplify. There's no need to. Using the approximation, we haven't done one of those yet during our couple of homework assignments we've done so far. So this is the first one. Using your approximation just means plug it in. Right? What do you get when you plug it in? And then make sure you solve. It's tempting to want to accidentally leave this as minus 3 over here. But you would need to add that 3 over the other side so you actually get what f of 2.1 is and not what is f of 2.1 minus 3. Right? You need to make sure you add that 3 over to the other side. Okay? Okay. Next one under our FRQ2 was our FF prime F double prime graph. So you really shouldn't be doing this one if you haven't already walked through your FF prime F double prime graphs from Monday. We did 4 of them on Monday, due Tuesday, or maybe you did them over the weekend, but you should have done those 4 already. Okay, this one came from 2017. The function f is differentiable on the closed interval -6 to 5 and satisfies f of -2 equals 7. We talked about, or did a couple of these on Monday, talked about the fact that whenever I see a coordinate point given within this context, I'm already thinking about the desired position formula. Here's my given position, my given time is -2, and then whatever my desired time is, this graph is called f prime. And so that just comes out of years of doing these. So I'd recommend kind of putting that into your arsenal as you're looking. Remember, with these FRQs, for that 1 point you will get next time. Remember, the goal is not to get 100% every time. The goal is, what can I do? What 1 point, what 2 points maybe can I get right the next time I see them? And so maybe that's the one you want to focus on for today. Okay. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments and is shown in the figure above. Sorry, I reorganized the page to fit better for printing, so it should be above. And then I talked about in the video on Monday, I always make sure to take very careful notice of what graph I'm looking at, because that, potentially speaking, is going to change how I read my function. Okay, and so then I'm going to be doing these in the following order: B, D, A, C, only because, again, that's how I've seen students do it in the past. So B, D, A, C. You could do it in whatever order you want. You can skip around in the video if you'd like, but I'm going to do B first because this is the one that one of the ones that we're kind of expecting, right? Something about increasing, decreasing, relative max, relative min, concavity, points of inflection. And I wrote out the table that we used back in Unit 3 in our Monday Monday video, notes video. And so I would recommend looking at that table if you need to, but what does it mean for F to increase? Well, F increasing means F prime is positive, and so this is asking me where on this graph of F prime is my F prime positive or above the x-axis. Some people like to think of it that way. Okay, and so this graph is above the x-axis from -6 to -2 and from 2 to 5. Okay, and then justify your answer. Remember we talked about the fact justify can be words or work. I myself am going to do words on this one because there's not really work that effectively justifies why this is true. But because f increases when f prime is positive, and f prime is positive on those intervals. Okay, this was worth 2 points for your answer with justification. 2 points. Okay, going down to D next. D says for each of f double prime of -5 and f double prime of 3, find the value and explain why it or why not. I say find the value or explain why it does not exist. And this one was worth 2 points, 1 for each. So 1 for f double prime of -5, 1 for f double prime of 3. Okay, so f double prime of -5 first. Well, I've got f prime, not f double prime. If they ask me for f prime of -5, that would be easy. This is f prime, 2, 3, 4, 5. F prime of -5 would be whatever the y coordinate is at that point in time, because this is f prime. But they're asking me for f double prime, so the question is, well, what is f double prime for my f prime graph? How do I get f double prime from f prime? Well, f double prime is the derivative of f prime. And we've written down several times now through our FRQ notes what a derivative is. So take a look. What is a derivative again? Derivative is slope. Right, so f double prime, which is the derivative of f prime, means f double prime is the slope of f prime. Well, f prime of -5 is this line here, and it has a slope of down 1 over 2. Down 1 over 2. It has a slope of -1/2. Down 1 over 2, and so that's 1 point. Second point, what is the slope of 3? F double prime of 3. Well, at 3, I've got a cusp, which means I don't have a slope there. This does not exist. And then your explanation, so here, go ahead and actually write that out. Okay. Does not exist. Your explanation needs to somehow reference like why you know it doesn't exist. And so when you look at the rubric College Board talks about the fact that on the left-hand side you've got one slope of 2, and on the right, this is a slope of 2 up to over 1. On the right you've got a slope of -1 down 1 over 1. It talks about the slope on either side. It's not the only way you can explain it, but it is one route through it. But somehow, again, talking about why do you know that that doesn't exist? And so if you've written out your explanation, you're not sure if it's good enough, feel free to take a picture of it, send it to me. I'm more than happy to say, yes, you're good to go, or to help you kind of clean up your explanation to help you get that point. But you would need to have some sort of explanation along with your does not exist there. Okay, so we're at 4 points. Going up to A. A was worth another 2 points, so we're at 6. I'm sorry, A was worth 3 points. So actually with A, you're going to be at a total of 7 points possible without even having done C. A says find the values of f of -6 and f of 5. So f of -6 and f of 5. Well, this is that desired position formula, and again, we did a couple of them in our homework video, or our F prime focus video from Monday. I'd take a look at them again. But the key here is I've got 1 point. I've got 1 point. I want a different point. And so I'm going to use this desired position formula. 7 plus the integral from -2 to the one I want, which is -6. And actually, for the record, your first point in this problem comes from using your initial condition. And so recognizing that this negative 2, 7 needs to somehow be part of determining f of negative 6 and f of 5. So using it correctly would be somehow using it within the desired position formula or some modified version of the desired position formula. And so again, if you're looking at your work going, I don't know if this counts, take a picture, send it to me. I'm more than happy to check that for you. But I'm going to use it within the desired position formula, like this. Your other 2 points then come from evaluating these two things, which is this guy's upside down. So let's go ahead and fix that. 7 minus negative 6 to negative 2. And negative 6 to negative 2 is this triangle here. 1/2 base of 1, 2, 3, 4, height of 2, and then I would leave it. Don't simplify, you don't need to. If you choose to simplify, you should get 3. Down here we have 7 plus negative 2 to 5 is the semicircle below the x-axis, so negative, and the triangle, 1/2 base times height. So the semicircle below the x-axis, so negative, would be negative 1/2 pi r squared. My r is 2. And then the triangle, 1/2 base of 3, height of 2, and then leave it alone. Don't simplify, you don't need to. If you choose to simplify, it should simplify to 10 minus 2 pi. Okay? Okay, your last 2 points here come from part C. Part C says find the absolute minimum value of f on the closed interval. So we're doing absolute minimum here. It's worth 2 points. And I shared in the video on Monday focusing on f prime graphs that when I see absolute maximums and absolute minimums within f prime, I always make that my last part that I do, which is part of why I'm doing C last. If I were timing myself and working through it, I would read that, and the first thing I would do is write down what are the possible places my absolute extrema could exist. Because a lot of times that piece, just where are your possible ones, will be its own point. And here that is true. You get 1 point for considering one particular instance of our absolute extrema, but I always write them all down myself. And your second point comes from then finding your answer with justification, and justification would be the work corresponding to you finding your answer. Okay, so absolute maximums, absolute minimums occur at one of 2 potential points. The first one are your endpoints. Well, my endpoints for this one are negative 6 and 5. And so I'm going to consider those. And then the other potential points are where your f prime equals 0. And so here my f prime equals 0 at negative 2, 2, and then 5, which I'm already considering 5, so I'm good to go. So negative 2 and 2. Now, the only one you actually had to consider in this particular case is the negative 2. The reason why is that the 2 part is the one you have to consider. The reason why is that 2 is the one that's actually a relative minimum, and so it could be a relative maximum. My f prime here changed from negative to positive, which if you look at our little f prime, f double prime table, when f prime changes from negative to positive, that's a relative minimum, and so it could be an absolute minimum. Negative 2 I don't actually have to consider, although I'm going to. But negative 2 I don't actually have to consider because negative 2 is a relative maximum, right? Because f prime changes from positive to negative at that point. It's a relative maximum, meaning there's no way it's going to be an absolute minimum if it's a relative maximum. It could be an absolute maximum, and so if this were to ask us to find both absolute maximum and absolute minimum, I'd want to consider both negative 2 and 2. Okay, so you got 1 point for considering 2 as a potential location. Negative 6 then, we already found negative 6 up here in part A. Now if you found negative 6 and you made an error in your work and so lost the point up here, you wouldn't lose it again down here if that mistake somehow accidentally helped you get the wrong absolute minimum. So if you did for some reason make a mistake that dropped this point really low and made it the absolute minimum, you wouldn't double lose that point as long as this work up here is not oversimplifying the problem, right? So don't double dock yourself. And again, if you're looking at yours going, I'm not sure if this is double docking, take a picture, send it to me. I'm more than happy to check it for you. Okay, we also found f of 5, same thing up there, right? If you made a mistake with your f of 5, you wouldn't double dock. And then f of 2, so I'm going to use my desired position formula again. F of 2 here is 7 plus the integral from -2 to 2 of f prime, which is 7 plus -2 to 2 is just the semicircle piece. So the -1/2 pi r squared, r was 2. And then f of -2, they actually told me, f of -2 is 7. So really the only thing I actually had to solve in this problem was this one. And so then the question is, well, which one of these then is the absolute minimum, the lowest point, the smallest value? Okay? And so maybe here is where you do simplify. This is 7 minus the 1/2 and 2 would cancel, which gives me 3. So I now know 7's not my absolute minimum, right? This one would be 7 minus, this is 4 times 1/2, which is 2 pi. 1/2 and 2 would cancel plus 3, which is 10 minus 2 pi. And then here you have 7, and then minus 1/2 times 4 is 2. So the question is, well, which one of these is smallest? You would not be expected to know exactly what 10 minus 2 pi is, but you would be expected to be able to approximate it. What is 2 pi around? Well, pi is about 3, and so 2 times about 3 is about 6. And 10 minus about 6 is about 4. So we know that this one is not going to be my absolute minimum because this one is bigger than 3. Okay? 7 minus 2 pi, well, pi is about 3. 2 times about 3 is about 6. And 7 minus about 6 is about 1. And so 1 is the smallest of all of my values here. And so my absolute minimum would be at, is my f of 2, which is 7 minus 2 pi. Okay. Okay, last one here. We have 2015 tabular data. So this one goes back to last week's FRQ focus, and you had one on FRQ1, you now have another here on FRQ2. They're not going away yet. We have Joanna jogs along a straight path for 0 to 40. Joanna's velocity is given by the differentiable function v. So I've got a restricted domain here, 0 to 40. Velocity, so I'm thinking velocity information. We've got velocity units here of meters per minute. That's then articulated, right? Selected values for v, t is measured in minutes, v of t is measured in meters per minute are given in the table above. We have used the data in the table to estimate the value of v prime of 16. We've done several of these so far. V prime of 16, we have velocity, so its derivative would be rise over run. 16 is right in here. This is worth 1 point, by the way, for being able to do this. So v prime of 16, we would have either 240 minus 200 or 200 minus 240, whichever you prefer. But if you, whichever one you choose, whoever goes first for the y values, its corresponding x also has to go first. So if you put 240 first, you have to put 20 first on bottom. If you put the 200 first, then you have to put the 12 first. And then as we talked about many times, don't simplify, leave it there. They didn't ask us for units, but I always tend to recommend tacking them in. Velocity was meters per minute, so v prime, which is acceleration, the derivative velocity, would be meters per minute squared. Remember, every time you take a derivative, a time element gets added in. If you take an integral, a time element gets removed. Don't simplify. There's no reason. If you did simplify, it makes 5, but it's a waste of time. Okay, B, we have using correct units, explain the meaning of this integral in the context of the problem. So this one is worth 3 points. First point comes from that sentence. What does this mean? And we've done quite a few of these. The integral from 0 to 4 of the absolute value of velocity was what? Okay, well, this comes from our particle motion packet. It's on the back side there. This is total distance. Right, is the total distance traveled don't forget your units in meters, traveled from t equals 0 minutes to t equals 40 minutes. And again, this is not the only possible explanation that you could write, but you do need to have correct units in there, meters and minutes, and then it does need to somehow reference total distance there. Okay? If there's questions on that, again, let me know. Okay, last 2 points for this problem comes then from the approximation, which is you're going to get 1 for doing the right-hand Riemann sum and 1 for your answer. Remember, you don't have to simplify at all, so once you set up your right-hand Riemann sum, leave it alone. If you simplify wrong, you then lose your answer point. So leave it alone. We talked about within our tabular motion day, so if you go back and look at last Monday's tabular data focus, we talked about different things to keep in mind, and one of them that I said at the time was with your Riemann sums, make sure you keep in mind any sort of modifier that might be there within the context of the problem. And we've seen a couple of those. There was an average one on either FRQ 1 or that tabular data day. In this case, our modifier is the absolute value bars. Okay. We're doing the 4 subintervals from 0 to 40, so 1, 2, 3, 4. But as I do these intervals and set up my right-hand Riemann sum, I want to make sure that I'm keeping in mind that it's the absolute value of my velocity, positive velocities. And so for the right hand, my change here is 12 for my first subinterval. It's 12. And then the right hand would be the 200, and 200 is already positive, so I'm going to leave it alone. Second subinterval changes 8 times the right hand, which is 240. Here's where you want to be careful. The third subinterval changes 4. My right hand is negative 220, but it's absolute value, and so this would be positive 220. Change 16, right hand 150. And then don't simplify. Here's where, if you had forgotten this negative, you would lose one of your 2 points, but if you left it alone, you would still get one of the 2 points because your work then reflects your error. If, though, you wrote negative 220 and then also simplified wrong, you could potentially lose both of the possible points. So don't simplify, leave it alone, right? Obviously, I want us to get both points though. So if there's a question on that, again, contact me, we'll go over it. Okay, C says Bob is riding his bicycle along the same path for 0 to 10, so he has a different restricted domain here. Bob's velocity is modeled by this function. Okay, so we've got b of t, which is velocity. We actually already used v of t up here, so let me call this call it v sub b, velocity of Bob. Okay, where t is measured in minutes, b of t is measured in meters per minute. Find Bob's acceleration at time t equals 5. So this is worth 2 points. First point comes from recognizing how you would find Bob's acceleration, because b of t, remember, is velocity. Well, so b prime of t, if I took its derivative, is the acceleration. Of Bob. And so b prime of t would be 3t squared minus 12t and then plus 0. So your first point comes from using b prime of t, recognizing that b prime of t is what's necessary within the context of this problem. And then the second point comes from then your answer, which is at t equals 5. What is Bob's acceleration? And so plugging 5 in. And again, don't simplify. There's no reason to. This is Bob's acceleration. If you do simplify, this simplifies to 3 times 25, which is 75, minus 16, which is 15 meters per minute squared. But there's no reason to. Okay, last part here is worth 3 points based on the model above from part C. Right? Find Bob's average velocity during the interval 0 to 10. Okay, so we're wanting average velocity here. So average comes from 4.4 in our notes. Average is 1 over b minus a, 10 minus 0. The integral from 0 to 10, and then average what? Average velocity. And so velocity is getting put in here, which for us is our b of t. Okay? Your first point came from being able to set this up, knowing how to set up average velocity. It's why I tried to emphasize it over a couple of different units as we went through, but you get another chance now to look at it within this problem. Second one then comes from your antiderivative, which means taking that integral. So t cubed is 1/4 t to the 4th. We have 6t cubed over 3, right? Adding 1 to the exponent, dividing by the new exponent, and 300t. And then your third point comes from your answer, which is now plugging in the upper minus plugging in the lower. I know a common mistake for people a lot of times comes from this back one, although if you made an error at any point in your antiderivative, this would be true, what I'm about to say, which is you would lose your antiderivative point, but if you plug in 10 and 0, plug in the upper minus plug in the lower, to your antiderivative, as long as you haven't oversimplified your problem, you can still get the third point in this problem. Again, 1 for the integral, 2nd for the antiderivative, 3rd point for the answer. And again, if you're looking at yours going, oh, I don't know if I oversimplified it, take a picture, send it to me. I'm more than happy to check it for you. Okay? Just let me know that you need me to. Okay, so we have our 1/10 out here. Plugging in our upper would be 1/4 10 to the 4th minus 6 times 10 cubed over 3 plus 300 times 10 minus plugging in the lower, which is 0 minus 0 plus 0. And then I am going to leave it alone because I do not have to simplify. Okay, that's FRQ 2. Again, you have 15 minutes per FRQ, so you've got plenty of time. With this FRQ 2 then, 3 FRQs, we'd be looking at 45 minutes to do these 3. This video, even with all of my extra talking and talking about the rubric and all of that, is still under 45 minutes, so you have time to really pause, to read through the problem, to annotate it, circle things, rewrite stuff, slow down, breathe, and remind yourself that you don't have to get all 9 points. Skewed percentages, right? With each FRQ, the goal is to identify what's one more point I can get next time. Okay, if there are any questions, let me know.